Okay, this video is for 11.3G, angle measures in polygons. So for the most part on this worksheet, we're going to be talking about the interior angles of polygons and different polygons with different numbers of angles. So it could be a triangle, it could be a square or a pentagon, and you can see the list of these here. Lots of different polygons, and we want to talk about what those interior angles add up to as a whole. And we want to talk about, in some of the problems, what each individual angle in these polygons are going to be. So first, let's take a look at problem number 2. Find the sum of the interior angles in the following polygons. Well, we know from class today that the equation for finding the sum of the interior angles in a polygon is n minus 2 times 180. Now, in number 2, we don't really need to do that. We know that a triangle has to add up to 180 degrees. But if you were to apply the formula, triangle has 3 angles. That's what n stands for, the number of angles in the polygon. So 3 minus 2 is 1, and then 1 times 180 is 180. Now, a nonagon is a 9-angle shape. So let's apply this formula to find out the sum of its interior angles. So we'll do 9 minus 2. Again, the n stands for how many angles in the shape. So 9 minus 2 times 180. Put that into your calculator. Make sure that you put parentheses in. So 9 minus 2 becomes 7. And then 7 times 180 equals 1,260. So the interior angles of a nonagon add up to 1,260. All right, let's move on. Now, this one, in this section of problems, and we'll look specifically at number 9, it says find the measure of each interior angle. So not just the sum of all the angles put together, but each individual angle, we want to know what that measure is. Now, the key here is regular. What a regular polygon is a polygon whose sides and angles are all the same. So between the sides and angles within that shape, they all have the same measure and length. Now, there is an equation for finding this as well. And that equation is this. N minus 2 times 180. So that finds the sum, so that's the same equation as before, and that finds the sum of all the angles in the polygon. And then we have to go back and divide that by how many angles there are. And once we divide that by how many angles there are, then we will know the angle measure for each individual angle. So let's apply that. A pentagon has 5 angles, so n is going to be 5. So we have 5 minus 2 times 180 divided by 5. 5 minus 2 is 3 times 180 is 540. So we have 540 divided by 5. So then the answer to 540 divided by 5 is going to be how much each individual angle is, and that is 108 degrees. So a pentagon, each angle is 108 degrees. Now, we'll skip those, move on to the back side. Now we're going to work what we just did, but backwards. So, in problem number 23, they've given us the measure of each interior angle, so an individual angle within, and again, our regular polygon. So each angle in this polygon is 144 degrees. So we want to take that and figure out what kind of shape we have. Do we have a pentagon? Do we have a hectagon? Or a decagon? Or, whatever it is. So we want to use the same formula we had. N minus 2 times 180 divided by n. So that is the formula that gives us, this one gives us the measure of each interior angle of a regular polygon. And then we want to set that equal to what that angle measure is. So in this case, that's 144. And now we have to solve for n. We do that first by multiplying both sides of this by n, and these two n's cancel out, and that leaves us with n minus 2 times 180 equals 144n. Now let's distribute this 180 inside our term. So 180n minus 360 equals 144n. Now let's subtract 144n from both sides and add 360 to both sides. So we are moving these terms around. Adding 360 to both sides cancels this off from the left side and moves it to the right side. And subtracting 144n from both sides cancels that off from the right side and moves it to the left side. 180n minus 144n gives us 36n, and that's all that's on the left now. And then technically 0 plus 360 gives us 360 on the right. Divide both sides by 36, and we get n equals 10. So, if n equals 10, that means our shape has 10 sides, and 10 sides is called a decagon. And that is the answer to that question. So a decagon has angles which each measure 144 degrees.